Today we will be using the multiplication properties of exponents. So let's discover what that multiplication property is. And the way we'll do that is taking a look at this first problem here. We've got 3 squared and 3 times by 3 to the 4th. So the best way to explain the property is to rewrite this in an expanded form without exponents. So 3 to the second just means 3 times 3. 3 to the 4th, well, that means 3 times 3 times 3. So 4 3's all being multiplied together. And let's count up how many 3's we have now. Well, if I count them up here, I have 2 3's. And this is being multiplied by 4 3's. That means we have a total of 6 3's all being multiplied together. And that makes 3 to the 6th power. Well, another way to think about this is with the exponents. See, if you just took that common base of 3 and counted up the exponents. Here we have 2 3's. And then add on these 4 3's, and that makes altogether 2 and 4 make 6 3's being multiplied together, and that gives us the same exact answer. So the rule that we're going to use when we're multiplying terms or common bases here with exponents, we're going to add up those exponents. So we can do the same thing with bases that are variables. We can take those exponents on that common base and add them up. So here we have 5x's, here we have 4x's, here we have negative 2, so we have to add on negative 2. Now notice that that negative 2 is going to actually take away from the sum of the positives, and we'll see that in a little bit. And then we also have negative 10. So we go ahead and add this up, and we have 5 and 4 makes 9. Negative 2 and negative 10 make a negative 12. So we can go ahead now and subtract because they have opposite signs. So when we do that subtraction, we're left with x to the negative 3rd power. Well, remember the directions ask us to simplify. Simplify means get rid of those negative exponents. So the way we're going to do that is we're going to think of this as a fraction and take those negative exponents, that x to the negative 3rd power, and switch its location in the fraction. And so when we do that, we get a new answer. So we take the reciprocal, one is left on top, and we have x to the 3rd power on the bottom of the fraction, and that is the answer that we want. Well, we got another example, a little bit different here. And what's different about this problem is that we have terms without the same base. Well, it's the same sort of procedure. We just use that commutative property. So the commutative property says we can take different numbers as long as they're being multiplied or added, and we're using the commutative property of multiplication here, and we're going to commute the terms of the same base next to each other. So that's the first step we're going to end up doing. So we'll take that x to the 4th, and I'm going to move this x to the negative 3rd next to it. So I'm going to bring it right over here so that I can add up those exponents. So it's 4 plus negative 3. I'm going to do the same thing with the y. See, y is the other base. That's the same. We have 2 of them. And so I'm going to take this y to the negative 1st and put it next to that y to the negative 2nd. I'm using that commutative property. I'm just going to add up those exponents just as I had done before, because that's the rule says I can do. And so when we do that, we're left with x to the 1st power because I had to subtract their opposite in sign. And over here I have to add them, and I end up with a y to the negative 3rd. I add because they are the same sign. Well, I still have that situation where I have a negative exponent here. So whenever we have negative exponents, we just take the part that's negative and we switch its location in the fraction. So when we do that, we're left with a simplified form without any negative exponents. So we have x to the 1st on top, and we can just write that as x. And then we have y to the 3rd on the bottom of the fraction. And there would be our answer. Well, a little bit more complicated problem is next. Letter D here. Now we have some coefficients in front of the x's in each of the terms here. And so we're going to use that same commutative property of multiplication. Everything's being multiplied here. So let's just take these coefficients, the numbers out in front of the variable, and bring them together and multiply them, because that's what's happening. And so when we do that, let's take our x's next. So we look at all the different x's that we have, and let's bring those next to each other and add them up. And so here we have add up the exponents, that is -2 and +2. So I'm going to take those and add them together. And then I'm going to take a look at the last different base here that I have, which is y, and bring those together. And we have y to the third and a y to the -4th power. So we can go ahead and do some work here by multiplying. Now when I do this, I'm going to multiply the 5 and the 2 first, using that commutative property, or maybe that associative property in this case. Group these two terms together. And I do that because I get -10, and -10 times 3 is an easy number to multiply. It just adds a 0 at the end, and so that gives me -30. And I count up the x's, and I have an x to the 0 power. We talked about that yesterday, what that becomes. We'll talk about that again in just a moment. And here we have a y to the -1st when I subtract those exponents due to the fact that they're opposite in sign. So we go ahead and do some work here. Anything to the 0 power we talked about yesterday was equal to just 1. So we don't have to worry about that. That just kind of cancels out. Now let's take those negative exponents and move those into the other part of the fraction. Take their reciprocal. So again, the common mistake we talked about yesterday is people want to move the negative coefficients to the bottom of the fraction, but don't do that. It's only negative exponents that we take their reciprocal of. Negative numbers always stay where they're at. And so we have -30, that's on top. And then down below we just have the y. Y to the 1st power would be okay as well. And that would be our answer. Well, another example here, same sort of thing. The difference here is that sometimes people get a little confused with the parentheses. Well, parentheses just mean multiplication because they're right next to the next term. So we're doing the same process here. We're just taking the coefficients and bringing them next to each other. Now this one we don't see the number between the minus and the y, so we can treat that as -1. So put that one next to the 6 as well. And so we'll rewrite those numbers out. We got 3 times by 2 times by 6, -6 that is, times by a -1. Now we look at the next type of term that we have, next base, and that's x. And so I see there's two types of x's here. We have an x to the -4th, and here we just have an x to the 1st power. We don't see the exponent, so treat it as 1. Now moving on to the last type of base, here we have a y, and it's times by y to the 5th, and another exponent of 1 since we don't see it, so y to the 1st. And then from there we just calculate what we've got left. And so we go ahead and multiply out those numbers. Here we have 3 and 2, that makes 6, times by, and then these two make a +6 since the two negatives cancel to leave us with 36. Count up the x's here. We've got x to the -3rd. I had to subtract because they're opposite in sign. Here they're the same sign, so I'll add them together, and that makes y to the +6th power. Well, from that point, we can go ahead and treat this as a fraction. Again, we need to do that because we have another negative exponent. If it was a +3 here, instead of a -3 on the exponent of x, then we just leave it as our answer. But it's not, so we need to take that negative exponent and its base and take their reciprocal, and that'll make the exponent positive. And so what we're left with is that 36 on top, a y to the 6th left on top as well, and down below we have x to the 3rd power. And there is our answer. Well, the first couple of problems you see, actually I think it's just the first one, it deals with asking us to find the area of an object, and it's going to be a rectangle or a parallelogram. So area formula for both are the same. It's just area equals base times by height. And so it's easy on a rectangle because all sides are 90 degrees from one another, and that are adjacent at least. And so that means we can just look for that 90-degree symbol and then take the two sides that are connected by them and multiply. So that's what we're going to do here. Take that 2x squared and multiply it by the 1/2 x. And then do the same process as you had done before. And so you just take the coefficients, put those next to each other, 2 times by 1/2, and then take the x's. Count up how many exponents you have. You got 2 x's here, 1 x here, and So you add up those exponents. Well, 2 times a half, half of 2, that equals 1. So it just makes 1x to the third power. And since we're dealing in area, we'll just write down units squared. Again, it wasn't necessary to write the 1, so if you left it off, that's okay as well. Another problem, the only difference between these two shapes is that we don't have right angles on this shape here, and we call this a parallelogram, just as a rectangle is as well, because the two sides that are opposite one another are parallel. Now again, when you're looking at a parallelogram that is not a rectangle, you're looking at this right angle symbol, and the two sides connected by it, which are the 2x, the height, and the base is perpendicular to that height, are the two sides that we're going to end up multiplying. So we're just taking that 2x and multiplying it by the 4x to the third power. And so when we do that, we go ahead and bring the 2 and the 4 next to each other. So this is the same thing as 2 times by 4. 2 times by 4 times x to the first power, because we don't see an exponent there, it's just 1. And then add the 3. And then go ahead and multiply. So here we have 2 and 4 make 8. And then we count up the x's. We got 8x to the fourth power. And these are, again, units squared. We don't know what the units are, so that's why I'm just calling it units squared. Well, we have a volume problem as well. So we'll call this one a rectangular prism. And so the volume formula is just taking the different dimensions here, this length, this width, and this height, and multiplying them. So it's just length times by width times by the height. And so we'll call this one the length, this is our width here, and this is our height going from the bottom to the top. And so you're just multiplying them, that's all it is. It's just seeing a figure, a geometric figure, and using algebra to solve for the volume. And so we're just taking that 3x squared, multiplying it by the 2xy, and then multiplying by that xy. So we go ahead and do the same process we had done before on the other examples. You're just taking the coefficients, the 3 and the 2, bring those together, and then you're bringing the x's, so counting up all those x's. Remember, exponents of 1 if you don't see the exponents, so x to the 2 plus 1 plus 1. And then do the same thing with the y's. Here we have a y to the first and a y to the first, so it's a y to the 1 plus 1 power. And then from there, just multiply out those coefficients. So 3 times 2 gives us 6. Count up the x's, and you've got 2, 1, and 1 make 4 altogether. And the y's, well, we have 1 and 1 make 2. And since this is a volume, now we're dealing in units to the third power. So we call that units cubed. If we knew what the units were, like if they were inches or miles or meters or centimeters, then we'd say those units to the third power. Well, the next part will deal with a term raised to a power.